Very good afternoon to all of you who is attending these live sessions on fluid mechanics. Really, it's quite interesting for us to deliver these 24 hours lectures on fluid mechanics, covering basic fluid mechanics course contents. It's quite interesting for us to deliver the phase-wise the fluid mechanics in a illustrated mode, which is quite different than any other way to have the mostly what we try to do it basic our objective to teach the fluid mechanics with a lot of illustrations. I do believe that we have succeeded on that to deliver the lectures with of the fluid on fluid mechanics with illustrations, with examples, and that's what I try to do it. And apart from that, many of the times we just reference to the three books. The most important books is Sinjal Simbala book. That's what give a really inspiring to you, and to look at that type of book where you have a lot of illustrations are there, and try to understand the fluid mechanics from the illustrations point of view. That's what we tried it, and we are quite encouraged or fascinated to get your feedbacks through Ask Me questions. Now, today I am present here in a live, okay, to take your questions and answer some of the questions, okay, not all. Definitely, I will carry forward some of the questions what you are asking through Ask Me question sessions. But today, let me first to tell you that really we are fascinated because total number of students registered, student and faculty registers more than 12,000, and 2,500 students are participating the assignments. So this number itself says that we are doing well. Okay. So looking that, let's have a very positive note to deliver these live sessions to you. Very positive notes, and I think as of now we have something like 15 are watching my live sessions. Okay, please put the questions, but that's what we'll try our level best to answer them. And most of the times I can say that we try to explain in video lectures. If you are not getting it, please come back to Ask Me questions where we can explain more detail as compared to this 1 hour live sessions. So with this, let's have the questions what is already we had in a Google file. That's what we will discuss it. Then we'll talk about the questions which are coming onlinely. Okay, so those things will take it as far after that. As of now, we have the two questions. I think if I look at the second question is how to get into a career in CFD. Okay, if you look at this, I think you first you please understand the fluid mechanics in the next levels, and the CFD careers, you have a lot of careers in the CFD, but your knowledge on the fluid mechanics at the basic level is a must. So please try to understand the fluid mechanics, the level, what is necessary for international levels. If you understand that, no doubt you can have a lot of careers in the CFD and its applications like earth science, the global climate change and all the things, all are the basic concept of the fluid mechanics and then the CFD applications. You can have a good career, but the basic things what I can advise you that please have a fundamentally strong on the fluid mechanics. Understand the fluid mechanics at the different level. That's my suggestion. Let's come to the next PPT mode. Next. This is what I am again telling you to, as I told in introductions level also. as a teacher, I do believe that you should read the parallel the books. Okay, the best books what I have given to you as a reference book, please follow the Sinjal Simbala or the FM White book. Those books, as a teacher, I always suggest you to please go through these books after hearing my lectures, which will be again clarify whatever doubt you could have. So that's my suggestion is please don't consider that all these things I could able to explain in your 24 hours scheduled lectures. It's not possible always. So please go through these books, and these books are very fascinated way it's written, the fluid mechanics, and that's what is inspired us to deliver these lectures. Again, I am repeatedly telling you to please go through these books, which is necessary for you to go to next level of the fluid mechanics. Next. If you look at what way we taught a particular lectures, like for example, if you talk about Reynolds transport theorems, never we started Reynolds transport theorems directly equations. We started a particular lectures with a series of illustrations. Then we commit to the equations level. So what my point to tell it, even if we spend less time at the equations level, but we try to make it the understanding of the fluid mechanics as an illustrations level. Like if you look at these illustrations, if you look at these illustrations, so the basic our idea is, again I am to convey you that we want to give a fluid mechanics as illustrations, and you should visualize the fluid mechanics. It's apart from understanding the mathematically fluid mechanics, please visualize the fluid mechanics. That's the reasons we talk about virtual fluid ball concept, we talk about this type of photographs, and finally what we have derived the Reynolds transport theorems. So this is the way we have been following this instruction style. So that's what our basic way to teach these courses. Next. Let's coming to the problems. The questions what you have asked it. What is the difference between a stagnation pressures and the static pressure? This question is quite interesting question for us. Okay, let's go to next slide. If you look at these are the slide what I used in my class. What is the static pressures? If you look at in a Bernoulli's equations, we define a three terms. One is a static pressures, dynamic pressures, and hydrostatic pressures. The static pressure is coming from the flow energy. The name is static pressure, which doesn't mean it's fluid at the rest. Please don't have that concept on this. It said the flow energy per unit weight, we define it here as the pressure. That pressure component we are defining it here. So that's the reasons. Please don't have the confusions between the static pressure and fluid at the rest. And if you have that, next. If you look at when you have fluid particles like these problems, okay, these are streamlines. The fluid particles they are coming in, because of the presence of this object, the fluid by force reduce its velocity tends to 0. That means it is the point the fluid particles becomes velocity equals 0. But by the time it convert the velocity head and the flow energy pressure to make it the stagnation pressure. So stagnation pressures have the two components, the flow energy head and the velocity head. That two combinedly, when you are putting a pitot tube, we measure these two terms, the flow energy head and the velocity head, because at that point the fluid particles which are coming in, it convert its velocity head to a pressure head as equivalent and make it a stagnant pressure. So that's what we you can understand it, what is the stagnation pressures and the static pressures. Next. Regarding the pitot tube, you can look at that when you have the stagnation pressures, that means we measured both those pressures, the static pressures and the dynamic pressures. So many of the time, because pitot tube can have a different positions, we can have a consider the elevation set with that. So the pitot tube measure the total pressures sometimes if you aligning the pitot tube in a different points. And here it's showing it where could be the stagnation pressures. That the point is there. Coming back. So pitot tube used to measure total pressures because it combinations of these two, the static pressure and the dynamic pressures. So that's what is the answer. So we have put it to that. Next. Water flows steadily vertically in a constant cross sections, neglecting the Bernoulli equations. Okay, you have to find out what is the relationship with the pressures and the velocity with respect to height. So as you know it, it's a steady flow, the vertical pipe, constant cross sections. Since it's a steady flow and the constant cross sections, you can say that you can easily use a continuity equations to compute it, velocity does not change it. So only the pressure changes with respect to height. We can easily using the Bernoulli equations, we can demonstrate it if there is no change in the velocity, the pressure decreases with height. It's a very simple problem. The next problem is equations what we have given is it's a part of the GATE questions. If you look at these questions very clearly, it's a Bernoulli equations, but there is a integrations form. These integrations forms allow us to consider the pressure variability, also the density variability. If I consider it the density variability, then it will be the compressible fluid. Density, because there is a integrations which allow us to consider the variability of density. So this equation implies as it's a compressible fluid. Since it's a Bernoulli equations, we derive along the streamlines, the basic assumptions what we did it, steady frictionless. So the options is steady frictionless compressible fluids. Next. I think there is a questions, what is a fluidity? I do believe it, these are the questions, it's not relevant to us, and please Google it and get this definition, what do you mean by fluidity? Okay, it's not part of the fluid, it's a description of the fluid flow in literatures. Next. Question 4, which is asked in a Google Doc, that's what is assignment 4 velocity answers. There is some points what is given. I think these are the minor mistakes what was there in assignments. We gave all this announcement for this question. Please please relook, ask me question sites, and we also the announcement, look at that. We have taken care of that. Next. The question number 5, it's quite lengthy. Okay, it's quite. Thank you for asking these big questions. Okay, from aerospace backgrounds. Okay, we also demonstrate the wind tunnels. Okay, very basic levels. If you look at your first question, what is the difference between vortex and vorticity? Please refer to my video lectures. Try to understand what is vortex, what is vorticity. Okay. Vorticity is a measure of the vortex, and the vortex what you can understand it. We just please go through this my lectures again and relook it, that what way I explain the vortex and the vorticity. Second question is quite interesting, that how you have taken the assumptions of solving the questions like steady, laminar, turbulent, 1D, 2D. It was not clear given, especially turbulent and turbulent. This is what I was looking for this to have this type of questions from the students. I really happy to get the questions from the students that how did you give you this type of assumptions while they're solving the problems. If you look at that, this is some of the art. You try to understand what could be the flow. That is what the basic things in the fluid mechanics to simplify the problems. And those simplifications of the problems, when you do it, we have to take these assumptions. And how they are relevant, are they your simplifications are correct? That what your knowledge of the fluid mechanics to take care of. Is the flow is laminar or the turbulent? That's what, it's not you to derive always a Reynolds numbers and find out whether it's a laminar or turbulent. But your understanding of the fluid flow problems can say it roughly, is it a laminar or the turbulent? Is it a one-dimensional or two-dimensional? Or the three-dimensional? These are your visual interpretations, the knowledge on the fluid flow. That what gives you a strength to put these assumptions. These are the reasons, if you look at almost all the problems, we have defined these flow conditions, then we have solved the problem. That's what is our intentional things, that students should know it, what assumptions they are doing it. And if that assumption they know it, then they know the problems accurately. That's our idea. I think I really appreciate these questions. Whoever asked these ones, it's a really fantastic questions for us, and we try to get it this type of questions for later on also. Okay. The question 3, sir, you have taken the constant is 2 by lambda. This is the questions what is there. The basic idea is for us to define a constant. If I define a constant 1 by 2 lambda, I can write a functions like this, which is a motion of the equation of a circles with coordinate of 0 and lambda. So that is the reasons we have put the 2 lambda, and you have put the lambda square is a radius that. So these trick how to get 1 by 2 lambda and the equation, you can consider some c value, but your equation format will be different. It will look like a equation of the circles, but it will have a slight bit different. So these are just a trick to define equations for a circles. That's the thing. Okay, it's a quite relevant. What is a source and sink flow? I do believe it. We have just 24 hours fluid mechanics course. We have to extend it 12 weeks. We'll discuss all the source, sinks, and all the things more detailed, more illustrated way. It's not to just tell what is a source and what is a sinks. Thank you for these good questions from question number 5. Yes, question number 6, it's quite interesting. I think this is we are teaching the Reynolds transport theorem. It's very undergraduate levels. Okay, it's supposed to have the doubt between Lagrangians, Euler's, and this system and control volume. Let me I just brief it in a live sessions. I cannot deliver full lectures here. See, if you talk about the systems, all these physical equations, all the physical equations satisfy that in solid mechanics. That means we define a control mass and the control volume. Try to understand that. The Reynolds transport theorems we are applying to have a relationship between the system and the control volume. At the system level, all these physical equations, mass conservation, linear momentum, angular momentum, energy conservation, all are valid, which is. But when you come to Euler and Lagrangian coordinates descriptions, next slides. This is next. Next. This is a description. How do I describe the fluid flow pattern? It's not a system and the control bar. Okay. So basically, Lagrangians is a description how the fluid flow pattern I can describe it. tracking the n number of the particles. The particle can change it, the mass. Particle can have a track. So, like the virtual fluid balls. So, the particle tracking the particles, can we define the fluid flow problems? That what very simple way is a Lagrangian framework. In case of all the frameworks, we don't consider is that particular the particle part level. We consider the average conditions, behaviors, and that what we represent as the Euler framework. These are flow descriptions. That is the way to establish the relationship between system equations to the control volume. So, control volume we use to solve all these fluid mechanics problems, what we have did it. So, please relook it, just think more about what is the difference, and I think that is what you can get it more details next. Yes, these are quite interesting questions, but I think I can give you a simple description of the flow separation, how does it take, how it affects the upstreams. But in this basic level of courses, I do believe it's necessary to discuss now. We can discuss any next level of fluid mechanics when I talk about flow separations. Next. Okay, so the question number 8, which we got it, very simple problems what we have solved it. These typical problems, if you look at what we have done it, sum of the force component in the x directions we are equating with change in the momentum flux. So, momentum flux is rho q v. So, there is no change of momentum flux in, because there is change of these flow directions 90 degree. Okay. So, only you have this influx momentum flux which is rho q v. So, v can be written as q by a. So, it is a rho q square by a. It is a very simple thing. This is a momentum change of the momentum flux. This is what the force acting in the x direction. It is a very simple trick of the problems where we can apply the Bernoulli equations, solve it, which is a q is not given to us. This is what is a gate question. Is it correct? It is a gate question. So, most of the time the gate questions given like this, where some of the parameters, some of the like q is not directly given. Please have a understanding on how to solve this type of problems. What are the, yeah. So, we will take their questions, whatever the questions they have now. Yes, so the first questions from Priyanka is about please explain the momentum flux sign conventions. Okay, let me explain you. If I draw the control volumes, then the control fast surface, I can know it the velocity directions, inflow or the outflow. If you know the velocity direction, you know the momentum flux. Is it a positive direction or negative direction? Inflow to systems or the outflow to system? So, these are very easy things. You draw first the control volume, draw the control surface, see in the inlet and outlet what is the velocity directions. Is it an inflow or the outflow? Rho q mass flux into v. So, you have a directions component along the v. So, you know it the momentum flux direction, is it inflow or the outflow. Sign conventions we follow it depending upon your coordinate, where you have x axis and y axis. So, do not confuse your sign conventions, which you can define any x and y coordinate system, but you try to locate your momentum flux direction, inflow or the outflow, or is it the inflow along the x axis or y axis, that what you can simplify at the control volume level. How to tackle problem of non-inertial control volumes? I think this part of the fluid problem we have not taken it. And I think this is, I cannot introduce here with a live how non-inertial frame problems would take it. I think it's a good questions, but I have not covered these things, okay, and I cannot explain this thing with a few minutes when you have the live sessions like this. A tube having 5, I think this type of questions, please put in, ask me, don't ask this theoretic numerical value to me to solve the problems and give an answer to you. It's not like that. You ask, we have the forums, you just put the questions of this type of things, we'll look at what could be your points, okay. Tips for gate preparation, I think that's this question is quite, I don't know, it's how to answer these questions for you. I can say that you just work hard and have a good fundamentals on fluid mechanics. And these are very basic questions. Courses, if you have a fundamental ledgers, and we've been solving some of the gate questions, if you look at questions are too easy to solve it, but still you need to have a fundamental knowledge. That's the reasons we brought control volume concept and all. Try to understand the fluid mechanics this level and you can solve the problems. So it's not a big issue, but that's what my suggestions. Yes, what is, sir? Please provide the solutions for the assignment problems. I think we are going to upload this, what you are looking at, we are going to upload it, whatever we have minor mistakes. But you see, being a teacher, I do believe it, many of the time we should do intentional mistakes. So that way we should know it, whether the students are attending to our class or not. Okay, we do the mistakes. I don't taking an excuse for that, but we some of the times we do intentional mistakes to look at how do you responding it, okay, to our classes. Okay, that's our idea, and I think we could have succeeded in that way. You can understand it. Each teacher is not a one way to teach a course. So teacher is know how active or attention to our lectures. That's the reasons we do the mistakes and we try to locate how promptly responds to our systems. That's our strategy. Anything? Gate subject study using NPTEL is enough or not? I think these are questions not to be asked to a professor. It's enough or not enough? Okay, I can say it that as I repeated earlier is that please have a confidence at the fundamental levels. If you have a fundamental is strong, you can solve it, because in a gate we don't give a repeat questions to anybody. So, okay, there will be no repeat similar questions. Okay, it could be the similar questions, not the repeat questions. So that's my point is, have a strong in fundamentals and try to solve these questions at the fundamental levels, not at the formula level. So that's my suggestion is, how do you prepare it that how much time you spend it to understand the fundamental books, basically the books from the international standard, Sindel Simbala, FM White. There are a lot of series of the international standards books are there, please follow them. That will be giving you confidence for next level to any exams, not the GATE, any other exam. You can do well, there's no problems. Yes. So we have few minutes left. I think we don't have much questions now. Yes, any questions? It is bit delayed, no?
Yes, just 14 seconds.
Okay. Yes. Any questions, please ask. Yes, please do some questions from basic of aerodynamics. Okay, we do understand you from. We'll try it, but as we already finished our assignments and all, and in this course we are mostly focusing in compressible flow, but aerodynamics morely compressible flow. Maybe next level what we'll go it, and there we'll look at how to target the compressible flow, and we can have a some of the questions from the aerodynamics level. But the concept what we are teaching it, control volume, applications of mass conservations, linear momentum, those you can apply it in also the problems in compressible, incompressible, but in compressible flow, aerodynamics level, that what we are not covering here in this curriculum. What is metacentric radius? Radius what is? Yes, I think please put these questions in a, what is metacentric radius? I think you are looking at definitions. Either you visit my lectures or put in ask me questions, will reply it. So please don't ask me a definitions to clarify here. It's good. The question has come from Himangsu. Okay, what is turbulent boundary layer? State some effects on the system. I think my course we have not come to the boundary layers, which is a very interesting part of the fluid mechanics. Because of that, we have introduced virtual fluid balls. The virtual fluid ball is a concept where we can easily explain the turbulent boundary layer formations. Okay, but in this lecture, since it is, as I said, is just eight weeks lectures, definitely we cannot complete the higher level of turbulent boundary layers. Please have a very nice videos are there, but letting see that what is the response is coming for next. We can go for a next level to explaining what is the turbulent boundary layers and how does it affects the drag force, how the flow separations takes place. All we can discuss when you discuss about boundary layer concept. It's okay. The questions from Mohammad Irfan is that is it NPTEL is enough for GATE or not? Okay, I think this is not question again to ask to me. You just compare the GATE syllabus and look at the GATE. So that is what our intentionally we are solving some of the GATE questions to just to give a confidence to you. Is it enough or not? That I cannot answer you, but I do believe it. You have a syllabus and our syllabus, compare it and think it that what we are doing it. Is there any scope of fluid mechanics in India besides structures?
Structural engineering,
Can you rephrase Tenzing? Is there any, can you rephrase your questions? Is there any scope of fluid mechanics in India besides structures? What do you mean by that? I'm not. Is it talking about career? Tenzing. Okay, this is questions from Himangsu again talking about boundary layers. Again, I think that's what is question. How does the Prindle numbers affect the occurrence of boundary layers? Again, to repeat you that this live session is not to ask the questions which are not beyond my area. No, that's what beyond my this 24-hour lectures. But definitely we look at these questions. When we develop the new level of questions, courses for the fluid mechanics. Why pipes of a circular sections are used for transporting the fluids is from Kisan Sao. Okay, I think you can try to understand it that you need to reduce the energy losses, reduce the frictional losses. So when you have the circular pipes, you reduce that component. The frictional losses will be the less as compared to the other pipe process. That is the way we follow it. So just look at some of these things. Mohammed Pran, it's what is the benefit of NPTEL certification course? I think this question is not for me. You asked maybe NPTEL certifications support systems, what is there? I cannot answer you that what is the benefit you will get it, but I'll tell you it in other way around. Now, when you have a course is developed at the NPTEL levels, which is as you can, as of now, you can know it that it is a next level of the instructions as compared to the what you are teaching in your college. The next level of course learning, having a certification, always you have a positive impact in your career graph. But what way it will come, that's what you to encash it. It's not the NPTEL will help you, but you to encash it, because you have got a opportunities to learn the fluid mechanics in the next level, and also get a certificate with some grades depending upon your performance, and those certifications will help you in your career path. But how? That is what your job, how you make it this interesting, the fluid mechanics part in this way. Please use larger size of pointer as well as change the color of pointer when you. I think these are not relevant to see that, but please have a, that's whatever we have a facility, we are teaching it. I know it, we may need bigger size and smaller size, but we tried our level best teaching on the blackboard to these ones. I think you do understand it that everybody has some degree of limitations, that you try to understand it. We are providing you the video lectures which are there in YouTube. We are providing these lectures, okay. All the things we have a ask me questions are there, live is there. I think if you have everything, then let's not have a talk about what could be the color and what way to design the things. Okay, it's okay. It's I do understand it what you are trying to ask me. Yes, any questions? Please have a, I think we have another 10 minutes. Just have a 10 minutes, please. Yes, please ask the questions, otherwise we are going to wind up, but the Deepak has asked us the questions, please provide the solution of assignment if possible. We are going to upload it. We are going to upload the solution of the assignments. The final exam pattern of the fluid mechanics. Okay, we are coming back to again exams. It's quite interesting. The students would ask about the exams, no? But you know what is the pattern of these exams patterns. You just visit the NPTEL sites, you can know it, what way they ask the question. Similar way you have to follow it. And so we are not having, but detail about the exam pattern, as I am assuring you, will put it in an announcement board. We'll put it in an announcement board much beforehand. They have exam on, yes, you have a November 16. Before that we will upload it. What could be our structure of examinations pattern. Hydrodynamic boundary layers, please explain, sir. Okay, I think again you are asking me the questions from boundary layers. I think it's quite interesting. You are asking me the question is the next level. It is inspiring me to take the fluid mechanics in the next levels. Okay, I'll take care of your questions when I develop the course for the next levels. So, any questions? So, if you don't get any other questions within 2 minutes, we are going to wind up these live sessions. Thank you very much for this afternoon to have a live sessions with you. Thank you.